Today, we'll explore why the derivative of the sine function is the cosine function. Let's dive into this beautiful connection between trigonometry and calculus. The derivative of a function tells us the slope of its tangent line at every point. We claim that if you take the derivative of sine of x, you get cosine of x. How can we verify this? First, graphically, by comparing the slopes of sine's tangents to the cosine curve. Second, by checking key points algebraically. Let's watch the graphic animation. Notice the blue curve tracing the slopes of the red sine wave. Observe, at x equals 0, the slope of sine is 1. Cosine of 0 is also 1. At x equals pi over 2, the slope becomes 0. Cosine of pi over 2 is 0. At x equals pi, the slope drops to -1. Cosine of pi is -1. The blue curve matches the shape of cosine perfectly. Let's break this down intuitively. When sine is increasing fastest, like near x equals 0, cosine is at its maximum value. When sine peaks at x equals pi over 2, its slope flattens to 0, matching cosine's 0 value there. Cosine is ahead of sine by a quarter cycle, explaining why the slopes shift left. A common mistake is thinking the derivative of cosine is sine. But no, the derivative of cosine is actually negative sine. Remember, derivatives of trigonometric functions often involve sign changes and phase shifts. Before we wrap up, two quick questions. 1. What is the derivative of sine at x equals pi over 4? 2. Why does the derivative graph shift left compared to sine? Think about the relationship between slopes and the cosine curve. In your homework, practice finding derivatives of sine and cosine. Next time, we'll explore the proof in more depth.